In this video we are going to explain how a machine learning model works. This information is necessary for you to perform the tasks required for our study. If you have never heard of machine learning and models before, don't worry, we are going to introduce the concepts you are going to need later on, when performing the actual tasks. So what is a machine learning model? A machine learning model is a computational model built by looking at historical data, so that a computer can learn how to make a specific set of decisions, in a specific context or domain. Don't worry, you don't need to know the details of how such models are built. You only need to grasp how a model is actually used to make such decisions and a little bit about how it works. You can imagine a machine learning model to be a sort of magic black box which receives some data as an input and produces an answer as an output. Let's take a look at a specific example. Now imagine that you work in a bank and somebody built a machine learning model to automatically decide which credit card applications from your customers should be declined, and which should be approved. Using the same diagram we have shown you before, you can now see that for this specific example, the machine learning model receives information about each application as an input, and it provides, for each application, a suggestion on whether the application should be approved or declined. Before we move on, it is important to clarify an important aspect about how a machine learning model makes such decisions. Each application in the credit card example is described by a number of predefined characteristics which we call features. Such features are used by the machine learning model to assign a specific suggestion, which we call a label. Still, we use the credit card application as an example. Here, each application is described by the features you see in this table, for example, credit history, and months since last delinquency. Here the model assigns to each application one of the two possible labels, either approve or decline. For the purpose of this study, you should then think of a machine learning model as an automatic procedure that takes as an input a specific set of objects and, by looking at the values of these objects, assigns to each one a specific label. Now that you have learned what a machine learning model can do and the concept of features and labels, it's time for us to provide more information about how a machine learning model makes such decisions. One way to describe this process is through the use of a set of rules. Using the credit card application example again. The way the machine learning model makes the decisions can be described by the set of rules that you see here. Basically, all the visual representations we are going to use consist of three parts. First, median values for each feature on the top. Second, rules. Third, legend area, where we explain the meaning of all the symbols and colors we use in the visualization. Please keep in mind, the median values here are useful in the later tasks. If you are not familiar with median, don't worry, just think of it as a kind of average value. Generally, we think a feature value is high if it is larger than the median of this feature. And if a feature of an application has a value smaller than median, we think this application has a low value of this feature. In this diagram, we have four rules, R1, R2, R3, and R4. Each line is a rule. And when an application comes, if its credit card is larger than 72. And months since last delinquency is larger than 12. Then it matches rule R1, which suggests accept. And if an application has a value of credit history smaller than 57, and a month since last delinquency value larger than 12. Then it matches rule R4, which suggests decline. As demonstrated, the color of each circle represents different labels, or suggestions in this credit card example. For the same set of rules R1, R2, R3 and R4, we can also present them in this way. In this table, each row is a rule, and each column represents a feature. For each rule in a row, the condition is placed at a specific column according to the feature it uses. Similarly, if an application has a value of credit card larger than 72, and months since last delinquency is larger than 12, then it matches rule R1, which suggests accept. And if an application has a value of months since last delinquency value smaller than 65, then it matches rule R3, which suggests decline. Keep in mind, a useful way of reading a rule is that a square on the right side always means the feature of this column is larger than the given value, and a square on the left means that this feature is smaller than the given value. For this set of rules, we can check those rules with suggestions that we are interested in. For example, we can find out the rows where the suggestion, accept, are given. Then we can look into the specific rule. Also, we can look at a specific column, and find out the rules that contain this feature. For example, here we want to know that what rules are using the feature trades with balance. So we check the column of trades with balance first, then we focus on the rule R2 because it has the condition, trades with balance smaller than 5. Here we can also find out that the median of trades with balance is 3. Similar to the previous visual representation, here we still put a condition to a specific column based on the feature this condition uses. However, here we use a black rectangle marked with values to represent the condition. If the rectangle is marked with two values, x and y, then it represents a range larger than x and smaller than y. And if the rectangle only has one value, x, marked on the left side, then it represents a range larger than x. For the rectangle with only value x marked on the right side, it means a range smaller than x. And a line with a dot on it marks the position of the median value of a feature. The median values are still presented on the top of the table. Here in this table, the third row represents the rule R3. If months since last delinquency is smaller than 65, then suggests decline. Before we move on, it is important to highlight a couple of things about how the rules work. In practice, an application may match multiple rules or cannot match any rules. And then other metrics will be considered. But in this study, you only need to report the rules that match the given description in most cases. If a model suggestion should be reported based on the rules it matches, we will give you more instructions. Now that we have explained all the concepts necessary for our study, it's time for us to verify that you have learned them before we can move on to the next steps. As soon as this video ends, please click on the Start Verification button to access the verification test. If you pass the test, we are going to introduce the tasks we need you to perform.